Nature is a battlefield. Now, a group of animal rebels emerge, armed with a new and deadly chemical weapon, ready to paralyze, kill, and even take hostages.
Nature has designed the absolutely perfect bioweapon.
Can anything stand in the way of Venom? In the baking heat of the Australian outback, the most venomous snake in the world, the taipan, stalks its prey. 700 times as toxic as a rattlesnake, the taipan's bite packs enough poison to kill more than 60 humans. As it enters a rat's burrow, it's armed and dangerous. In an instant, it strikes. In seconds, the rat begins convulsing, its internal organs under assault by a complex mix of toxins that ensures its death. Venom.
If you're a snake, having venom is a great asset because it means that you can grab an organism, inject it with venom, and then let it go, and you don't have to fight with it.
For hundreds of millions of years, the world's top predators have relied on speed, or their size and sheer strength, to overpower their victims. But venom shifts the balance of power.
When we think of natural selection and evolution, we think of animals chasing each other and needing to be fast or needing to be strong. But venom changes the rules a little bit. It means that the small can defeat the big. It means that the slow can beat the fast.
Inside a tiny drop of venom, there's a minefield of toxins, a sea of exotic chemicals, some bafflingly complex, others so strange, it's taken scientists years and millions of dollars to copy just one.
This is the Australian mulga snake. So this is a brown snake. What we've got here this time is a death adder. They're actually related to the cobras. So what we're doing is we're milking all of these snakes so that we can have the venom to study in the laboratory. You have to get the venom, obviously, from only one source. It's got a good little yield on him. That's something you see a lot of variation in snake venom, is the color of it.
Sometimes the process goes wrong.
Like I had one bite from one of these kinds of snakes where it bit, swung the fang, stuck it in, swung the other fang, stuck it in, swing, and just walked across my hand. I had a series of puncture wounds going across it. That was fun.
A dose of anti-venom saved Fry's life. But every year, 125,000 people die from snake bites. No anti-venom works for all snake bites because venom is so incredibly varied.
Venom is the ultimate in the movable feast, where not only do you get big variations from one species to another, but even within the geographical range of a single species, you can get quite pronounced differences in the venom composition, where they might have a different menu, you might say.
Fry has dedicated his career to working out why venom is so diverse and so deadly. Could its evolution be the answer? Fry already knew venom was a combination of deadly chemicals that worked in unison.
Think of it more of like basically a gang beating you to death with different shaped iron bars. It's a concerted, multi-dimensional attack on your body.
His quest to understand venom would take him 5 years. For Fry, just knowing it was complex wasn't enough. He wanted to know where all those chemicals came from and how they evolved.
It's a lot like sort of doing a molecular detective story. What we do is we break it down. We separate all the different components out into individual components, do a wide variety of tests and other analyses to find out what makes it work, what makes it kill, and how can we use it.
Fry first tested the effects of hundreds of different snake venoms, observing their terrifying impact on animal tissues. Some dissolved flesh like acid. Some made organs like the heart burst from the inside out. Others caused instant paralysis. He then used the latest technology, called liquid chromatography, to separate out the chemicals within each venom. On these graphs, each peak indicates a different killer toxin within just one venom.
So what we've done is we've separated this complex mixture into each of their individual components, where these have been collected into their own vial. We now have a fingerprint of this venom.
What these venom fingerprints revealed was startling. The chemicals in each snake venom had evolved from proteins. Not just any proteins, but the universal building blocks used in almost every animal body to govern the most important physical bodily functions, from the circulation to digestion and even the chemistry of the brain. The twist was the proteins had evolved into new versions that could kill.
So the snake venom proteins don't come out of thin air. What they are is they're mutated forms of natural body proteins, often ones involved in very important physiological processes.
A snake's venom glands are biological warfare factories. When venom enters a victim, the killer proteins wreak havoc.
You can think of it as a smart bomb. It's built for the inside of the body that it's going to, and it's going to work there because that's where evolution has designed it to go.
So how does this mechanism work in practice with the most venomous snake of all, the taipan? To see the effects of its venom in action, Fry experiments on his own blood.
We've just taken a not small amount of my blood out, and we're going to use that. We're going to add taipan venom to one vial and leave the other vial alone, and then we'll be able to see the difference. So what I'm doing is adding the taipan venom to the blood. This is my blood. Without any venom, this is my blood on taipan venom. You can see what it's done to it. It's turned it into a solid clot. Now imagine this is my blood, but my blood actually inside of me. Obviously, this is not going to do good things. By making all those millions of tiny little blood clots, all your blood clotting factors are being used up. What this means is that you now can't clot. So you'll be bleeding out of your gums, your ears, your nose, everywhere else. It's not a nice way to go.
The taipan's venom evolved from proteins that form clots in its own blood to heal wounds. Once injected, it reduces its victim's blood to a mixture of massive clots and a liquid that leaks from every orifice. When the taipan bites a human, venom surges into the body and peppers the bloodstream with millions of tiny blood clots. This triggers a cascade of deadly effects, shutting down the liver, kidneys, and lungs. All it